So far, they're using that's what the sickness of they get die.
Good afternoon, everyone. I'm Gokul Srinivasan. I'm the Senior Partner Solution Architect from AWS, supporting Quilt. And as part of this session, we will be looking into the generative AI that's emerging, specifically in the healthcare and life sciences. And we will look into the art of the possible. And this is something that we are essence from the various different initiatives that our customers and partners are focusing on at the moment in the context of healthcare and life sciences. But these are not production ready yet because it's still evolving, they are maturing. But these essentially might be the trends that we might be seeing once they get into the production system and the use cases become more prominent, hopefully by the end of this year or in the Q1 of next year. So we wanted to share this as an insight about what we see our customers are focusing on. So it kind of generate an idea about what is the possible solutions that we could create together using the AWS services. So with that, I'm structured this into two different rounds, an overview of generative AI from a technology perspective. Then we will get into the nuances about the healthcare and life sciences use cases. And the artificial intelligence and machine learning is something not new to AWS. So Amazon as an organization is using AI and ML technology for the past 20 years. From our e-commerce platform, the Amazon.com, our warehouses, the Alexa and other Amazon devices, and also the AWS services in the form of SageMaker and other machine learning technologies. So it's not new. So what essentially Amazon is doing is through AWS, kind of democratizing the overall AI and ML capability through a variety of AWS services. And as of today, with this 20 plus years of experience, there are over 100,000 customers who are building this AI ML technology using the AWS services. And so far, most of the development has been happening via the SageMaker, the Amazon SageMaker, the ML Ops platform, where it's just not being used to develop a machine learning model, but to kind of develop, train, deploy, and operate the machine learning models at scale from the smaller startup to large global enterprises. And now, Amazon is also releasing the Amazon Bedrock, which many of you might have heard over the news. It is not in general availability yet, but it's available in limited edition. And what Bedrock essentially provides is, it provides a serverless LLM foundation model based generative AI capability that the customers can use to invoke and use generally available foundation models and build their generative AI capability. So Amazon Bedrock is upcoming and Amazon SageMaker is already existing and has matured. And this is essentially how Amazon and AWS are enabling our ISV partner, the individual independent software vendor partners, to build AI and ML solution at scale. And then within AWS, you get opportunity to play around with a different variety of hardware. So when we look into the AI ML, very specifically the generative AI space, there are three constraints that the customers are facing. One, the cost of training these models is pretty expensive because it requires just not a typical or traditional CPU, it requires a high performance GPU capabilities. So the cost of operating such high performance GPU is significantly higher. And then the performance is the second aspect. And when it comes to the performance, it's not about the operational performance, but in order to train a foundational model using large data sets, we are talking about terabytes of data sets that's available via the internet, it's not in petabytes. To train a model with such a huge volume of data, the performance is going to be another key challenge. And the third component is latency. Once we train the model is operating, how fast the response of these APIs and inference endpoints are going to be. So for this, there are a variety of options available in the form of hardware and GPU capability. And AWS provides a broad range of capability that's custom tailored for every customer use case and customer needs. And the last but not least, the practical use cases of generative AI. So one of the proven and the most adapted use case of generative AI is code completion. So Amazon Code Whisperer is a service that's launched and it's operational that helps customers to auto-complete and auto-create code based on the business logic that's been explained. So this is something that got launched recently. And what we have seen is up to 57% improvement in productivity. So Code Whisperer is an IT productivity platform. And using the Code Whisperer success story and the learnings, the Bedrock essentially supports the additional capability using which customers can start building out enterprise-grade application. Okay. And then looking specifically into Bedrock, what essentially Bedrock does is it provides a serverless capability to build the generative AI solutions. And what Bedrock does behind the scenes is it provides access to a variety of Amazon-built LLM models like Titan, and also third-party LLM models from Anthropic and AI21 Labs and all these third-party proven LLM and foundation models. So using Bedrock, it becomes easier for customers to invoke and access these foundation models via an API. So the provision of the servers and the capacity planning, everything is handled by Amazon Bedrock. And a simple API-based invocation makes it easier to use this foundation model. Now, this foundation model and the API invocation is good from a development perspective. But when we are looking at the production-grade implementation or the regulatory aspects, the data security, the data protection becomes the centerpiece. And that's essentially where the AWS VPC or virtual private cloud comes in play, where these foundation models, most customers are not going to train and create new foundation model, but rather fine-tune the third-party and the industry available foundation model, fine-tune using their corporate data set. And once they fine-tune the foundation model using the corporate data set and they create their own version of the model, these models are stored and posted within the customer's VPC. So this way the customer is not going to lose access to the data, not going to lose access to the foundation model. They still can operate within the regulatory and the compliance guardrails. And then the next aspect is the identity and access management. So the Bedrock is integrated with the Amazon IAM. So you could go with the granular control and all the security and the resource policy that you would be applying for any of the other AWS services. And finally comes in integration with other tools, because once the foundation model generative AI solution is built, it needs to integrate with other applications, other enterprise applications, other enterprise workflows. So the integration with other AWS services is something that's automatically being provisioned by the Amazon Bedrock. So that essentially is how the construct of the Amazon Bedrock is being laid out. And many of the customers, since Amazon Bedrock is not available in production yet, many customers are using Amazon SageMaker to start building up these capability. And the vision they are having is build that capability with the Amazon SageMaker. And Amazon SageMaker already provides most of these third-party LLMs via the AWS marketplace that can be registered and used in the Amazon SageMaker. So the customers are building their generative AI solution using Amazon SageMaker. And the vision they have is to start shifting into Amazon Bedrock once the service is available. But the investment and research into these generative AI capability is something that's already flowing. And before we get into the healthcare specific use cases, would like to call out a key aspect about what is the foundation model and how this is different from the traditional machine learning and the AI capability that's already existing and operating in the industry. The key difference is the parameters. So the foundation models has billions of parameters compared to the millions of parameters that the AI/ML models were providing earlier. And what it means is using these billions of parameters, it has now the capability to ingest the internet scale data. So the data ingestion and understanding the context based on the user input is something that was not existing in the traditional AI/ML models, which are operating within the construct of a corporate. Now, this parameterization is essentially what's enabling the foundation model to be already pre-trained, and it can understand the context of the industry and the internet scale data set, and then fine-tune using RAG and other capabilities that the corporates are building. And with this fine-tuning, the models now understand the corporate context. Corporate context and said who this organization is, what was the typical type of information this organization hosts, and able to respond back based on the contextual data within the corporate reference. So with that, we will look into what essentially are the healthcare and life sciences organizations are focusing and what type of applications and use cases they are solving using the generative AI capability. And since a vast majority of the audiences are in the life sciences space, I will focus heavily on the life sciences and not get too much into the provider or the health insurance. So the key use cases that we would like to highlight, we will go deeper into each of these use cases. One, on the genomic research. Organizations are trying to solve problems in the protein folding and on the clinical trials and the drug discovery. So that is one area where ISVs and the genomic research organizations are trying to use the generative AI data and use this to augment their existing research activities. The second component is all around the customer service operations, essentially the CRM operation, and improve the productivity of their customer service representatives. And this is one area where, in my opinion, it's going to hit the market a lot sooner, because already through the usage of IVR and other advanced technology in the customer service area, there is a significant amount of integration and the usage of the natural language processing that has matured in the CRM space. Now, generative AI essentially is going to take it to the next level, bringing in a lot more productivity to the CRM space. So it might be industry agnostic, but healthcare and life sciences are heavily investing in this specific space. And then with regard to the care coordination and the personalized medicine is another area where there is a huge amount of investment and the model tuning that's happening within the industry. And finally is around the synthetic data generation. This is not going to replace the traditional data, but what's happening is using the traditional data, a lot more contextualized and synthetic data is being generated using the generative AI technology. And this will be used for purpose-driven research, because one of the huge challenge we have heard in the industry is availability of industry-specific or research-specific data that's needed to train and evaluate the various different models. And that's where the synthetic data is going to play a role. And from a business model perspective, what we are hearing from some of our partners is to have the synthetic data generation capability and then monetize that data through exposing and selling that data via the Amazon data exchange. So where they could monetize the data by selling it to third-party agency without really compromising on the privacy. So it's all anonymized and de-identified tokenized data where there are no PHI and patient-specific information. And the industry can synthesize this data and sell it to the broader organization. Now, if we look at this, the specific aspect, how the foundation model and how the foundation model integrates with the end state application. And please feel free to stop for any questions if there are industry-specific use case that you are trying to solve using the foundation models. The first one with regard to the gene and the protein sequencing. One of the way that the foundation models are being employed is to synthesize the laboratory reports and all the various different images and then create a summarization information. So that's like a first step where the summarization technique using the generative AI capability is being adopted. That gives a first step for all the research scientists to look through the huge volume of the gene and the laboratory data. They have the summarized piece of information, using which they are using, they use that summarized data to decide their next course of action. And here the biggest advantage that's being coming out is the ability to scan through millions and millions of documents at a much more rapid speed. So the industry fine-tunes the available image model, specifically to call it from Stability AI. They are using the image to text models that is available. So Stability.ai is one of the popular image to text modernization model. So they use that model, fine-tune using their existing data sets, existing images, and then use the outcome model to summarize the data using for all the all the new data sets, image data set that comes from the industry. The second one with the call center summarization. So this is a virtual assistant that's being employed. And the way this call center summarization solution is operating is using the IVR technology and the CRM platform, specifically Genesis and Salesforce are a few examples I would like to call up. Integrate that, so that way whenever there is a customer request that comes in during the pre-call, post-call or even during the call. Using the IDR and the data, the standard operating procedures that's available within the knowledge management repository, the foundation model can integrate and create a summary of providing the context of that particular call, provide the history of the context, and also provide the next best action and the recommendation to the physical representative that's interacting with the customer. So this is the second use case. And the text-to-text model and the decoder models are extensively being used with regard to this call center summarization. And the third one being the training the dataset augmentation. So indicated, it's predominantly a text-to-text model that's being used for the text summarization. And this follows the principle of an encoder-decoder model, where using the encoder, they train on the existing data set. And then when they want to augment and create synthetic data using that existing data set, they use the decoder principle to generate a subset or a superset of data. And this is really predominantly used in the biopharma manufacturing space, where they want to create more synthetic data to understand the behavior of the reactor and the capability planning of those different reactors. So this is one model that's being used to create a huge volume of synthetic data and train and also performance test all these new and bioreactor technologies. And finally comes in the conversations, chatbots, and the virtual assistants. And the traditional chatbots and the traditional assistants were predominantly rule-based, where the sequence are being programmed. But with the chatbot-based technology, what essentially is happening is existing conversation with the human-centric conversation is being fed as an input, and the chatbot learns it through the AI/ML technology. It learns how to interpret the context, what type of historical information to retrieve, what are the systems the call center representative is accessing. So it looks into all those different activities from a human-centric approach, learns, retrains that model and have it available. So it provides a virtual assistant to the human-centric approach to begin with. And once the model matures, the intent is to move away from the human-centric approach and let the chatbot drive a lot of his productivity and a customer engagement. So that's essentially are some of the top use cases that are evolving and most likely will be in the market in our perspective by the end of this year, or at least by the early part of next year, once they are ready at the production state. And across all these models, the most important aspect when it comes to the corporate implementation is around the data security and the data protection. And having all the data secured within the enterprise environment, where Amazon S3 is one of the most common and the most popular data storage for unstructured data. The way we are envisioning how Quilt would be operating and supporting of the evolution of the generative AI in the healthcare and life sciences spaces, rather than already the Quilt ensures that your data is protected within the Amazon S3 and doesn't move out of the Amazon S3. The data is protected, the privacy is ensured. But rather than directly accessing the data and contextualizing the data, which becomes an important part of your machine learning and generative AI tuning, the customers can use the Quilt data product to contextualize the data, that take the machine learning model, the generative foundation model, and then pass the Quilt data product as a prospective input to the foundation model. So the models understand the context based on the data product, the data packages, and the existing data. The data is protected within the boundaries of your own corporate. And then contextualize the data, use prompt engineering to validate the accuracy of the data and the responses. Where prompt engineering is a mechanism where you feed in the question and get the response and validate. It's about fine-tuning your question rather than the program. You tune the question, optimize it in a specific way, and understand how the model is responding. And the more you optimize using a human interactive prompt engineering, the model gets the ability to understand the question and give the appropriate response. So that essentially is one way that organizations can start adopting the capability, use the RAG and the fine-tuning using the data products, and then conduct the prompt engineering to achieve the outcome of the generative AI models. So, and these are the additional healthcare and life sciences use cases where you could start exploring. And depending upon your use cases, certainly could request that send across the request to Quilt, and we could explore about how to mature these use cases and start building your industry and organization specific outcomes. Okay. And just wanted to call out so for folks who are not aware, Code Whisperer is something that's already available in the market. So you could start with the Code Whisperer for your coding productivity. And that's already integrated with all the AWS services like Cloud9 and also with third-party IDEs like Visual Studio. So this is something that people get started with to improve the productivity from a development perspective. And you could use the SageMaker Jumpstart to get started with the generative AI application development. And if you are interested in adopting with Bedrock, you could reach out to your AWS account representative and get a preview of the Amazon Bedrock, which is still not in general availability, but for specific partners and customers who are interested in exploring generative AI, AWS provisions the Bedrock capability. So you can start experimenting your workflow around it. Okay. So that's pretty much what I wanted to cover and bring to your attention about what's happening in the healthcare and life sciences space in the generative AI. So happy to take up any questions or any clarifications immediately.
Kind of wondering, I'm not sure if it's an AWS statement or your personal views, but how is AWS looking to address bias in this infrastructure? In particular, when you mentioned the piece about using the infrastructure to generate potential training data, that to me seems like a feedback loop that could rapidly tilt conclusions or generated information. Okay. What's the take on that?
So a couple of things, right? So the generative AI enables from a productivity perspective, but the validation of the generative AI based solutions and the outcomes, it needs to be subjected to a significant amount of validation. It is going to begin with the human-centric validation, and that's essentially where the model maturity comes in play. And a lot of the organizations, what they essentially wanted to operate is within the peripherals of their corporate. So use generative AI like a virtual assistant and a productivity tool. And then based on the continuous feedback loop is essentially how the models are going to mature. And the second component becomes the contextualization, because most of this foundation model are trained based on the internet available data. So it is capable of answering a broader range of questions, but they are not the subject matter expert. So contextualizing the data, so there are different models like RAG being one, and then comes in the fine-tuning model and the parameterization optimization. How well you fine-tune the parameter to get the outcome that you expect. That's essentially where the entire generative AI ops comes in play. So deploying the model is the most easiest part. Then continuously contextualize the data, validate that outcome, and then the approval mechanism. That's where the prompt engineering is so crucial. So you ask the same question in n different ways, the generative AI's response is going to be different. So the more you do the prompt engineering, fine-tune the model, get the needed outcome, and then authorize the model then becomes capable of understanding the user's expectation. So that is the only way that the model is going to mature over a period of time. And the three parameters are, as I highlighted, right? The cost, performance, and latency become so very important. So the more the industry context model comes up, the enterprises are going to adopt those industry-specific model, like a life sciences genomic research specific model. Once it's trained on the genomic-specific data and it understands the genomic-specific context, the enterprises are going to start adopting those industry-specific models for their use cases. And the second component, as Anish highlighted earlier, there is an important aspect of the shared responsibility model. So AWS as a cloud provider provides the infrastructure to rapidly build, scale, deploy, and operate this model. But to fine-tune and govern this model, it becomes the responsibility of the customers and the partners who operate and who really provides the context about what data this model has access to and how relevant this data is for the end use case. And the standard operating procedure, I'll take the example of the CRM application. The standard operating procedure, even across organizations in the exact same industry, the SOPs are so very different. So the SOPs that's trained with organization A, let's take with the insurance. Geico, I'm just going to take for example purpose. The operating procedure within Geico would be different from Allstate. So you tune a model with the Geico's standard operating procedures and try to deploy that model for another organization. It is not going to give the exact response. So this tuning, the continuous evolvement, is essentially how it's going to mature. And the validation is all going to be human-centric and human-supported. So the more the humans are going to authorize and validate these outcomes, the model has the capability to learn by itself and start contextualizing the responses in accordance with the enterprise context.
I have a question about data security. How do you pass, if we work on Amazon, do you pass in like the data to OpenAI or?
No. So this is how the process is going to work. So once you have the foundation model, you deploy the foundation model within your VPC, and you own the control about who can access your VPC, just like any other application. So the models are going to be deployed in your VPC, and then you contextualize and tune the model using the data that's available within your VPC. You could also use outside the VPC, but that's the VPC contained data is essentially what's being used. And the model never leaves your VPC without your permission, unless you want to deploy the model outside the VPC. So you have the absolute control over the model. And how you want to operate, you just follow the principles of least privilege. So limited user get access to your model, and just treat the model like your any other data. So you want to expose your data from an S3 and make it publicly available, you have the authority to do so. But AWS under no circumstance can read your model, access your model, or even use the data that you use to contextualize and fine tune your model. So it's going to be within your VPC network, and you have the total control about what you can do with the model and what are all the applications that can have access your model.
So the data, your own data, never leaves VPC.
No, it's you. It's everything is in your control. So just consider the Bedrock or SageMaker as another application that can read your data, and you have the control about what that application should do. And by default, it does not leave your VPC or your peripheral. And unless you authorize and you make explicit programs to have it accessible outside your VPC. So it's all protected, and you have the absolute total control of the model as well as the data that you use to train your model.
It's so open. One, please.